6-2, the one you actually did y'all's first circuit on. We only did the first activity, but the next lab we're going to do all of it. I think somebody, or the lab books, or the textbooks and the lab books, anybody check? Yeah, that's what I thought. So I need to see those, especially the lab book. The way this lab book is set up is it's about twice as big as it's supposed to be, because what they do is they duplicate the labs for doing them on the PLC and doing them on Logic Pro, and I have no idea why they do that, because you could do either one of them on Logic Pro. So the lab book is a lot thicker. We're not going to do any Logic Pro labs this semester, and in fact, from what I understand, Logic Pro is not. Our Logic Pro is not in the new textbook. So if you get the new textbook, then you won't get a copy of that you can use. But we're not going to do the Logic Pro lab anyway. In advanced PLCs, we'll be okay. Recently in advanced PLCs, when we did sequencers and all this other kind of neat stuff, we didn't have enough inputs to support that lab, so we did it on Logic Pro. But I think what we're going to do, if you're taking the advanced PLC classes, we're going to actually let y'all wire up one of these guys. And we're going to use the 1100 PLCs. So let y'all play around with those. So what you'll do is you'll wire them up, and then we'll do the labs the rest of the semester on that. We might let y'all hook up some stuff on. We're going to start using the sign-off sheet, and this is the sign-off sheet for the class. This will be up on that front desk up there, because we had mass confusion with that in lab too. You can see why we do sign-off sheets. It's hard for me to keep up with who's next and stuff like that. But what you're going to do on the sign-off sheet is you're going to let me know what you need, whether you need help or whether you need sign-off. We don't do these I don't do this at the same time. Okay. So we have two columns in there aligned. So it says if I need a help, I'm going to put a check mark in what column 1. If I need a sign off, column 2. Then you're going to put one of your team members is going to come up there and sign this off. And then when you're back at your lab station, up on the black strip at the top, every lab station has a number on. And what I want you to do, I want you to put your number on that. So what I do is I'll go up there, and there may be 5 names on there, and I'll mark them all off, and I'll get a sheet of paper, and I write the station numbers on there, right? You understand? So if you don't write your station number on there, I don't know where to go, and that way I'm not doing names, I'm going to stations, right? You understand that? It's just so much easier for me to do it that way. It says fill in these columns over here before you start these columns over here. Okay, y'all understand that? And so there's a lot of room. We have people to get sign off. So that's the sign off sheet. Where is it going to be at? On the front table up there, right where I said it.
You mean well, not at the front where your office, that little office is.
No, I'm not going to be in the office. I'll be
in front of the
right. The lab station right in the front of the office, the one that don't have the PLC on it.
Okay.
Now I'll give that up when we take the test, because we got 14 machines out there and we got 16 students. So what I do is I bring in laptops to do that, and then I'll go in the office during the test, but that's the only time I'll be in the office. Are we okay? So as soon as somebody gets a new lab book, I need to look at it and see how they arrange, so we can figure out exactly how these labs are going to go. I do have some run off for the next 2 labs. If you don't have your lab book today, then you should be okay. Thursday, we're going to meet class in the mechatronics lab. So we got a team coming in from Washington, D.C. that wants to look us over. So we'll be lecturing. We'll go over the test. So the start of the class, we'll go over the test, and then we'll look at Chapter 7 which is where we get into actually learning how to do logic with relays, learning how to do logic with relays. If you take the advanced PLC, we'll learn how to do logic with instruction or contacts. Everybody okay?
What lab are we in?
We're meeting over in, y'all know where the robotics room's at? Yeah, the hall building, at the hall building. 107 will be open, but 111 is actually the one right next to it. That's where we went to first class when we looked at the manufacturing lines. Okay. That's where we'll meet at. Are we okay? Yeah, no, I don't really know. Yeah, I think the homework labs are due today, right? Okay. And y'all turn them into the to be graded box down there. Like I said, it's got 196 on it, but that's the advanced PLC class. And I hadn't had a chance to relabel them, but we'll use those same drawers. So tell me what happened during the lab. The one we just did Thursday. So what were some of the problems we had? Not picking the right processor. Yeah, we found out, and unfortunately I didn't go down and check that out, but if you're using the 1000s, we're going to use the MicroLogic 1000. Don't use the Data Highway one that they specify because that don't work. What's some of those problems we had? Another problem we had, everybody that was on the 504s, the SLC 504s, everybody did it wrong. You did the lab, the circuit right, but you configured the program wrong, right? You understand? So the problem we have, and I can understand that, and I thought we covered it pretty well in class, was that the textbook, the lab book says use these ports, but you got to understand you just can't use what's in the lab book. You have to what? You have to use what's on your PLC. So the 504s, we have an input module that's in slot 1, and we have an output module that's in slot 2, right? You understand? So what you have to do is you have to take these addresses that they're giving you in the lab and adjust them for your PLC. Everybody understand that? I know the lab book told you to use N0/0 and that kind of stuff, but if you used N0/0, when you checked your rung, it says it was okay, but when you try to upload it, then you got an error, right? Because that another problem we had was when they were configuring the CPU, some of y'all forgot one little detail. And what was that? Yeah, to put the number of slots on the rack. So what happened is you went in there and you put in the two IO ports where they were, or slots where they're supposed to be at, but then the default was a 4-slot rack, and you had a what? We have a 7-slot rack, right? You understand? And it's the very top one. What you have to understand is that we can attach multiple racks together. And what they do on this, it actually supports. So first thing we have to do is select the what? Yeah, we have to select the processor, and we have a 941. A 541, and somebody selected the what? The C, and it didn't work. So we have a 541, a 1747 541 processor. And then what's the next thing we have to do if you're on those? Configure IOs. And we have 3 racks that we can connect together. And the problem is that some of y'all were choosing the second one when you should have been working with what? The very top one, right? And we have a what rack? Yeah, we have a 7-slot rack. And then the CPU all automatically jumps into slot 0. And then slot 1, we would find the number on our input device. And then slot 2, we would find the model number on our output module, right? Are you okay on that? Everybody okay on that now? And that gave y'all a lot of problems. Like I said, everybody on the 504 basically followed the lab blindly. And didn't configure, some of y'all didn't configure your rack. Some of y'all left it for a 4-slot rack. Some of y'all entered the addresses just like it was in the lab book, and y'all gonna have to remember that because that's the way most of these labs are written until we start actually assigning them ourselves. Everybody okay? Now, when you first install when you first, I'm not gonna say this. When you first install an Allen Bradley PLC, the first thing you have to do, and this is not covered in the textbook, but I need to show y'all that. We have 2 applications. We have the actual RS Logic 500 application itself, which is a little ladder. And then we have another application called RS Linux. Now, so this will come when you install the RS Logic software on a computer. If you're using one that's already installed. Now, normally, if the PLC's been around for a while, you're not going to have this problem. But when you install a new PLC, the first thing you need to do is configure. So what's going to happen on RS Linux? This is going to show every device that you have configured a driver. So what is a driver?
Program.
Close. Hardware. A driver is a program that controls a certain piece of hardware. So basically your operating system is made up of hundreds of drivers, but Windows cannot anticipate every device you have, right? You understand? So this is why every once in a while when you plug a little new USB stick in the thing, one thing neat about USB is originally what we had to do anytime we plugged a new interface card into these machines, first of all, you had to assign an address. So the card had all these little, we call them bit switches, that you flip, and you would literally assign the address. And then you'd have to go into the operating system and tell it where that address was. But when they started saying, well, you know, why don't we just store this information on a memory inside the port itself? And when this guy comes up and reports itself, then why not let the device configure the operating system? And we refer to this became known as PNP, plug and play. So just about all our devices now are PNP devices, which means you plug a USB stick in there, it comes up and it says, hey, I'm here. Your operating system says, well, do you have a driver? And it does what? And you'll see it pops up there. Sometimes it'll pop a little thing saying installing software, and that's what it's doing. It's adding what? The driver for that device to your operating system. So the operating system is just hundreds of drivers, and then a program that ties that all together, we refer to it as a shell. And what that shell does, it allows you to control the operating system. So this is Windows Shell right here. It's called Explorer. And what can I do with Explorer? I can launch other applications. I can create files. I can delete files. I can move stuff around. And that's basically what we can do. We can launch applications through our shell, right? You understand? These applications don't have drivers. And that's why they're called applications, because what they do is they apply the operating system to do what? To perform a task. Everybody understand that? So when you do, so what we have to do on this one, when we work RS Linux, is we have to configure the driver. So this shows me right here. So we have 2 drivers installed. We have a Data Highway 485, which uses an RS-232 interface, and then we have an Ethernet driver installed. So what you would do is you just go to Communications, and then Configure Drivers, and then you select the driver that you want to install. You'll see that? We have two drivers because the 1100 uses a Ethernet. We're using the 504, so it uses the DH485, so I'll just select that. This hooks up to one of the old COM ports which we used to have on our computers. Allen Bradley still uses that on their older CPUs. In fact, it's even on the Compact Logic 23 over there, which is one of their new CPUs. And what they're trying to do is trying to keep it downwardly compatible, right? Y'all understand that? Of course, just about everything's going to Ethernet IP or Profinet, which is the same thing. Normally, you have to select a COM port. Your new PLCs are not going to have COM ports in. But what happens is what you do is you buy. Where's it at? Yeah, we call them dongles. So this is the dongle right here, and what that does is take a USB and converts it over to the RS-232 interface. And as soon as you plug this in, what happens? This takes a little knowledge. Anybody know where we did? How do we find out which one it popped up at? I'll have to find it. If you're running Windows 10, what you probably need to do is type in control panel, because and then we'll go to System and then Device Manager. So what Device Manager shows us is everything that is controlled by the operating system. So everything that has drivers installed for the operating system is in control panel. And then what'll happen is you'll insert a COM port, and what you'll do, and this is what you need to do, because what you need to do is you can either randomly choose COM ports until it finds it, or you can come up here and when you plug it in, you'll see which COM port pops up as soon as you plug in your dongle. And then that's the one when you go into configure RS links, that's the COM port you'll choose. That makes sense? So how do we get there? Control panel, device mat. Well, you can get through system too. Control panel up to Windows 7 had a link on your start menu. Okay. When they came out with Windows 10, I guess people were screwing around with it so much they left control panel off the start menu, but it's still available. So what you do on Windows 10 is down under your in your run option, just type in control panel, and it'll pop up there that says desktop icon, and you can pin it to your start menu, your taskbar across the bottom, or you can pin it to your start menu, which is graphical on Windows 10. You can also on Windows 7 or even Windows XP, you can get to it by going to computer. And you can right click on computer and click on properties. And this will bring up this exact same window right here. It'll pop up. And then you can go in. By the way, on Device Manager, if you're having problems with something, there's going to either be a big red X on the side, which means it's been disabled, or there's going to be a question mark out there, which usually means you don't have the driver for that device. So what's nice about the control panel is if you're having problems accessing something, you can tell real fast where your problems are. Right? You understand? But what you'll get is as soon as you plug that dongle in, you'll get these COM port LPT listings right here. Just click on it, and if there's only one in there, then that's no problem. But if there's multiple ones in there, then choose the one that pops up when you plug in that dongle. Okay? Because it's a PNP device too. Everybody okay? So mine's on what COM port? Mine's on COM 4 right here. It's going to be USB serial port that's being simulated as a what? As a COM port. Everybody okay? And then once you choose that, then you go to configure. All you have to do is just say auto configure, and it'll go out there and figure out exactly what that thing needs to do. This is the problem right here, though. If you don't have that COM port, you could go through each one of these. Right? How long would it take you to do that? A long time, right? Everybody okay? When it says it's okay, then now your COM port is configured for RS Logix. Also on RS Logix, if you're looking at multiple devices, you can only monitor one device at any one time. So when you're running RS Logix, right here under comms, you can say who's active. And then this right here will show you who's out there. So what you can do now, if you got multiple devices on a network, you can check which one of these devices you're going to be working with, which ones you're going to upload programs from or download programs to. If you don't do that, then you might be sending your program to what? Wrong one, yeah. Everybody understand that? Now what I'm going to show you now, this is just to show you how similar these PLCs are. I don't have it hooked up, but we'll look at it. This is Siemens' newest programming application for their PLC. It's called TIA, and the latest version is 14. And TIA stands for Totally Integrated Automation. So this is their programming application. Okay. And this is what it's a little more graphical. So if I want to create a new project, I'll come over and click on that, and then I got to give here on RS Logix. You give the file a name when you save it, right? You understand, or when you upload it. Here, what you do is you give it a name when you create it, which is more in line with what most computers do. Are we okay? I'm gonna just go take the default program.
You said it was total integrated what?
Yes, isn't that right?
Oh, okay.
Then it pops up, and what's the first thing it asks me to do? Right here, what's the first thing it asks me to do? Configure device. So I'm going to click on that. And of course, this shows me the two devices this thing here supports. I'm sorry, then I'm going to do what? I'm going to add a device. Okay. This supports the controllers and then the HMI panel, human machine interface, HMI panel. When you get out to industry, most of the time, they don't use a lot of push buttons anymore. They program everything into a what? Into a touch screen, kind of like your computer. Controller, then I come over here, then I got to do what? Select the CPU, right? You understand that? So what do you notice? I mean, everything that we're doing. So we got a DC, DC, DC. And this is the one we got. Now, where would you find this information at? On the side of the PLC, right? Y'all understand that? Now, you can do this without having y'all can create offline. All your programs are created offline anyway. So you can create a program without a computer actually being hooked up to a PLC. But you still got to know what PLC you're using. You still know how to configure it, right? Y'all understand that? Everybody okay? And you can, so what I'm doing now, I'm not even hooked up to the PLC. And this is the PLC. Next thing we would do is we could go ahead and program, or we could set up a communication, which would be this guy right here. And we'll talk. Okay. Here's the project tree. So it's just like the project tree in Allen Bradley's, right? And then program, they program now the big difference is that Siemens calls their PLCs, they don't call them rungs, they call them networks. So what we do is, and here's our basic commands. You can, here's your instruction set right here. Right there. Here's our bit instructions. What I like about this, if you want to add anything to your general instructions, you can just drag it in over here, and then after that, so look, basically what? Yeah, basically the same. So I would have to know. Here's my power. I would have to know the addresses on this thing. This guy here, address is a little different. For one thing, they use I for inputs, but they use Q for outputs. Yeah. And I guess why they chose to do that, it's a German company, and output in German might start with Q. But the reason they did that was that Allen Bradley people are constantly getting the O key confused with the what? With the zero key. I mean, all the time. I even do it myself even now every once in a while. Of course, the problem I have here is I try to enter an Allen Bradley address. But yeah, we start off with Q, and then of course you would have to know what address is your PLC is at, right? The 314s that we have over in the lab, you choose where you want your IO addresses to be. So the IO addresses are all soft. They're not hard. So you can choose what range you want them to be, which I really like. If you take the advanced PLC class, we'll go over there and we'll play around with programming the we won't be programming the 314s themselves. Another thing that I like about Siemens is it's got a built-in simulator, so we don't need a Logic Pro. It's got a built-in simulator that you can install. So what you can do is you can load your simulator up, and it's got all these push buttons and lights and stuff that you can actually check your program out before you actually do download it to the PLC, which is really slick. I don't know if the new version of Allen Bradley software supports that or not, but we need to find out. So I just wanted to show you how similar it was between the twos. Yeah, if we added extra modules, this is where we'd come in and we would identify which type modules we stuck in this. Now this is what I refer to as a hybrid PLC, which means you buy the basic PLC, which has so many inputs, it has so many outputs, it has an internal power, most of them have an internal power supply in there. And then what do? You snap additional modules over on either side. You got two sides. Each one of them take different things. I think the IO module go on the right. But then we have another types of modules that will go over to the left. I think your communication modules go on the left. So if it didn't support, if you wanted to use Profibus instead of Profinet, then this is Ethernet, but Siemens refers to it as Profinet. Profibus is kind of like it's what we call a bus topology. You know what a bus topology is? So what is a topology? Huh? Well, it's actually the way the network is. Connected together, and we have three basic topologies, and then variations of those. We have what we call a bus topology. So a true bus topology, what we would do. So DeviceNet is a bus topology. Profibus can be, but we have one media that runs the entire length, and then what we do is we put taps on the thing, and then this would drop off to our different nodes. A node is something that connects to a network, right? And then you have to terminate each end. So you have a special little resistor pack that you put on each end to keep the signal from reflecting. Then we have variations of this. We have what they call a daisy chain bus. And when we look at the Amatro line Thursday, we're going to see how that works. So this is a daisy chain bus right here. And so daisy chain means one after the other after the other. This is the one we're using. And what you do on these connectors, you got a little switch on here where you can turn the terminator on or off. So what you would do is on all these in the center, you would turn it off, and the one on the very end, you would make sure you did what? You turn it on. And I'll show you that switch on there. And they refer to this as a what? Daisy chain bus. Ethernet uses what we call a star topology. So a star topology, what we do is we have a center unit like this. In the old days, we called it a hub, but most of the time now we use either a switch or a router. And then what we do is all your nodes just come in here and attach. So every device has its own cable. And this is Ethernet. This is star topology. Even wireless is a star topology. We have an access point somewhere, and each computer is connecting to that access point through the air. And this is called what? Star. You see, I got that name, right? When you draw it on paper, in real life, they go all over the place. But somewhere you got a set. Now, what you can do is you can divide this into subnets. So if we did this, we would enter a right, and this right here might be another switch. And then the switch would connect. It would have its own network of computers. What a router does is a router learns these switches. It learns routes to these different switches. So when you call up and you say, okay, I want to, and we identify on the IP address, we have two things. We have what we call an IP address, and then we have a subnet mask. The way the IP address works is from the most significant digit toward the least significant digit. This is what we call the network ID. And then from the least significant digits toward the most significant digits, this is the node ID. And then you have a thing called a subnet mask that tells you where its separation occurs. Okay. So if I came over here and looked at the subnet mask on this computer, now to understand subnet masks, you got to understand binary. Oh, no. So this is the configuration on my computer. So this is the IP address 172.25.101.101.99. And then below that is the subnet mask. Now what you would have to do is you would have to take each one of those octets and convert it to binary. And then you would take the subnet mask and convert it to binary. So my subnet mask would be this in this situation right here. 255.255 if I get this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 2, 4, which would be this. This is the IP address is the 32-bit address. Well, this would tell us that this portion of the IP is my network, and this portion of the IP would be my what? Would be my node. But what you would have to do is you would have to convert the IP over to what? To binary, to actually be able to see that. So that subnet mask identifies what portion of the IP address is the network ID and what your router does, it deals with this guy up here. Yeah, the network ID. And it decides which way it goes depending on which route you're telling it to take. Right? Does that make sense? Which is pretty good. So routers allows us to take a network and divide it into multiple networks, right? You understand? And each output on the router can address a lot of computers. And then a switch, what it does is it routes from used to a hub. What would happen on the hub is that when this computer wanted to connect to a computer, they don't care what it was. What the hub would do, it would broadcast that information to everybody. What a switch does, it's a computer. What it does, it memorizes the IP and the MAC addresses of every computer that's connected. So what it does, if I'm trying to send information to this computer right here, when I specify its IP, it'll come over and go to that computer right there. And what it does, it leaves all the other outputs free to do what? Communicate with other computers. So what happens, now this computer right here could not communicate with that one, but it could do what? It could communicate that way. These two guys could communicate and they wouldn't conflict with each other. So what switches did is switches increased the star topology by magnitude, the speed. Because now you're not broadcasting all through the network, right? You understand? Well, that's what the switch does. So you don't see many hubs anymore unless you got a real low network. Switches have been around. The other topology we have is what we call a ring topology. How would y'all think a ring topology would go? Yeah, we draw it in a circle. So ring topology, every computer basically repeats. So it's not only a receiver, but it's also a repeater. The most widely used method that prevents conflicts altogether. So Ethernet uses something carrier sense multiple access with collision detection. So that means you're sitting there listening to the network. If there's nobody on there, you put stuff on, you put a packet on there, you come off, you release the network. You start putting a packet on there. As soon as you put a packet on there, somebody else saw it was free. They put a packet on there. You have a collision. All the data gets garbage. Everybody comes off the network. They come back and off a random amount of time. Then they try to come back on. Right? You understand that? Token ring did away with that. So what happens is we have one computer which will generate a token, and then it starts passing that token. As long as the computer does not need to put a packet on the network, it just does what with that token? It's going. The computer needs to get that, needs to put a packet, it waits on the token. The token comes in and it holds that token. It sends the data out. And then it does what? Releases the token. So here we have no collisions at all, which is pretty neat. So this is token. Oh, it's a ring topology, but most of the time when we use a ring topology, we use what we call a token ring protocol. Now we have different ones, but these are the three main ones: bus, star, and ring. Right? Everybody okay? Of course, what most of your PLCs are going to now, they're going to Ethernet, or they call it Ethernet IP, or they call it Profinet, which is basically something. Which means now we're going to have to assign IP addresses and subnet mask and other new stuff, right? I'll try to show you how to do. We would do that. Okay, what else do we? So the lab, everybody, any questions on the lab?
So this is what we're gonna be doing in lab today?
What's that? No, we're going to be doing lab. Y'all did, everybody finish up lab 6, or did everybody finish 6-2, or somebody else still working on that a little bit? Almost through, right? Then we're going to do lab 6-4. 6-3 is a Logic Pro lab. So we're not going to do any of the Logic Pro labs in this class. I've ran off some copies of that, for the people who don't have their lab book today, but from what I understand, the lab books are here. Everybody understand? Everybody okay? Huh? No, they're down at the lab. These are all. We're going to do 6-4. It's got 2 activities in it. We're going to be doing. Oh, that.
You didn't want us to do activity 2.
No, we're not going to do that. We're going to skip over 6-3, and then we're going to go 6-4. We're going to do 2 activities. You notice, what happened to my lab book? Oh, it's up here. I got one. Huh? We're not going to do activity 2 in the first one because I've already, some of y'all's already turned that in. 6-4, we're going to be doing both activities. And you're going to do what? You're going to take turns, right? Y'all understand that. So how does that work?
Sign in now on the sheet up by your.
But how does, but you're going to take turns, right? Y'all understand that. So one person's going to be at the computer. The other person's going to be aiding that. Both of y'all are going to be doing it if you want credit. If you want to leave while your person's doing there, then you don't get credit for that lab. Everybody understand that? Okay. So both of y'all are working on the computer at the same time. Not on the computer. One guy's basically, or one student's basically the leader, right? You understand. The other one is I guess we call him the technician. You identify that on your lab form, right? Everybody understand that? So whoever did activity 1 in 6-2, the next person is going to be in the front, and every time you're going to do what? You're going to swap position, right? Everybody okay with that? So I've got 6-4, that's the next lab. 6-2, don't it jump 6-3, 6-3 isn't in the Logic Pro lab? Then 6-4 has 2 activities. Okay. There's some drawing in here, guys. You need to make it your drawing good enough or legible for us to see it right. Straight lines, no curved or crooked lines. Everybody understand that? Okay. This person right here didn't do step 1. So what did they do? This has been graded by Nancy, by the way. By the way, on page 92, if you can't see it, it says assign the input ports as indicated in the following. This is what got y'all, a bunch of y'all in a bunch of trouble, right? You understand? What trouble did it get you in?
92? That's
32, I'm sorry.
Oh.
I don't have my, 32. If you're on the 1000s, this right here will work. If you're on the 504s, the SLC 504s, then you're going to have to assign the addresses according to the PLC that you're on. Everybody understand that? Okay. So what y'all need to do for me is do what? Mark these out and put the correct addresses on here. Everybody okay? Huh? No? Page 32. It says assign the input ports as indicated in the following. If you assign those ports on the 504, it's not going to work. So I want y'all to mark them out and put the right ones that y'all are going to use on there, right? Everybody understand that? Yes or no? So it says switch 1, then it says PLC input port. It says N:0/0. What you're going to do is mark out the what? 0/0, or just mark out the 0 and put a what there? 1. Okay, everybody understand that? What are you going to do in step 3? You're going to draw the connections, right? Everybody understand that? And what are you going to do in step 4? For the PLC. So what are you going to do there? Well, what you're going to do there is you're going to put the addresses on there, just like it's been displayed, right? You'll understand. And what else are you going to do? You're going to assign the symbol or the label that you give that name. Everybody okay? Yes or no? And then we're going to do activity 1 and activity 2. And activity 2 is just another circuit that we're going to program in, but it's just a little bit, it's a little different, right? Everybody okay? Any questions on that? Everybody okay? So any questions about what's going to be on the test?
Say it again.
Any questions about what's going to be on the test? Yes or no?
Yeah, I got a question. Floating point number. I don't know, maybe I've seen it, Adrian.
Floating point numbers and fixed point. First of all, we have what we call integers. What's integers? It's a number without a fraction, right? Okay. Or whole numbers. And then we have what we call fixed point numbers and floating point numbers. Well, I don't know if I can set this calculator up here to do fixed point. Let's see. Oops. No, we can't set this calculator up to do fixed point. So your microwave, y'all have the ability to enter time on your microwave. Your microwave uses fixed point. Cash registers use fixed point. Okay. So what fixed point means, it means I would come over here and I would set up a decimal point. Okay. And what would happen is I would enter my first number, and my first number would go right there. Then I would enter my second number. It would automatically shift this one there. The decimal point never moves. And then my next number would be right there, right? I come up here and enter my next number. The 1 would move right there. The 2 would move right there. And my next number would pop right there. Notice what never happens. Decimal point never moves. It just moves past the decimal point. So the decimal point never moves. And we call this fixed point. Floating point means I would come over here and I would start typing this, and then I would enter a decimal point wherever I wanted it at, and then I would start typing numbers. This is what we call floating point. So this calculator don't do it. I use fixed point math a lot because when I'm calculating grades, usually we round the grades to 2 decimal points. Well, what I do is I just set up 2 decimal points, right? You understand? And then I take your grade, I multiply it by 100, and it automatically rounds it for me. It puts the decimal point at 2 decimal points. We don't do that much anymore now because the Blackboard does that all for us. What also, floating point math allows you to use exponents. So what I can do now is I can come up here and I can enter a number like this, and then I can come over here and put EE10. Now what does this mean? Well, when we use exponents on our calculator, we know that exponents has a base, and then it has an exponent. But when we use this exponent key on our calculator, the EXP or the EXE key, some of them call it X10, some of them call it EE. On these, the base is always 10. So when we come up here, we'd say 123.45 times 10 raised to whatever power we give it, like to the third. Now, when we start dealing with those numbers, how big can our numbers be? They can be huge, but they'll always be rounded, right? You understand that? That many digits. Everybody understand that? This is what we call floating point. So when we start looking at the number in advanced PLCs, when we start actually start dealing with math and stuff like that, if you take that class, when we look at the range of the numbers that we can represent, which ones are going to be the biggest? Floating point. Right? You understand that? All your other ones are going to be limited to a range. So if I use 16 bits to represent, if I use a word to represent a number, the biggest number I can represent is 1,048,575, and that's it. Right? You understand? If I represented that same number and then added an exponent, then use a certain number of bits of those 16 bits to represent an exponent. Right? You understand? Then we can come up and do what? Represent huge numbers. So if I use 14 bits to represent a number, and then 2 bits to represent an exponent, right? You understand that? Then that would give me up to the 4th. I mean, we can go ahead and start moving that around, 10 to the 4th. And so what we have the ability to do is represent very large numbers, but they're going to be what? They're going to be rounded to so many digits. Most calculators calculate the 13 digits and display 10. And they calculate 13 so they can round. By the way, what is a common log? A common log is just, it's 10 raised to some power, and the log is what 10 would be raised to. So if I had a log 4, what would that be? 10 to the 4th. A log 5 would be what? 10 to the 5th. That's all common logs are. It's just they don't give you the times 10 because the base. So common logs, the base of the exponent is always 10, right? You understand that? And it's going to be 10 raised to some power. Well, that power is what? That's what they give you when you take the log of a number. And then we multiply it by 10 and call it a dB. Another thing that somebody asked me, and yeah, we need to get to that, is about the ASCII code. And this is one of those things that's hard to teach because you got it so in your mind, right? So this ASCII code is a binary code, but to set the ASCII code chart up in binary would be very common. So let me turn off. Where's it at? Right here. So the first two columns, these are what we call control codes that we would be trying to send codes over to the information. And you still pop into these, won't you? Now what you do, notice the columns are labeled MSD, right? But what would the rows be? The least significant digit, right? Everybody understand that? So if I wanted to look up the ASCII code for uppercase K, what I would do is I would read the column number. So what column is it in? Column 4, row what? B. So this would be the ASCII code for E. So what you do is you take that hex number that's the chart is laid out, and then you convert it to what? Binary. And that's the ASCII code. So the chart is laid out in hexadecimal. Why is it laid out in hexadecimal? Well, it makes it smaller, right? You understand? Instead of putting all these bits up there in the rows and columns. I've seen ASCII code charts laid out in decimal. You got 128. We can't put it in a metrics anymore, right? You understand? Well, that's ASCII. And ASCII is still in wide use today, even on the internet. They call it Unicode 8. Unicode something 8. It's an 8-bit code, that's ASCII. But even on Unicode 16, the lower 256 characters are still ASCII code. ASCII is still around even on the internet.
I have a question. How you calculate the number of
Combinations? Okay, so how many combinations can we represent with 2 digits of base 10? Huh? 2 digits of base 10. So I'm gonna start counting. 1, 0, 1, 2, 3. I keep going, and I get up to 99. That's 2 digits. I can't represent any bigger number. I cannot go any with 2 digits, right? You understand that? So when we calculate the number of combinations, that's what we're doing. We're starting with 0, and we're seeing how far I can count before I exceed what we give y'all. Well, how do we do that? How do I know? Y'all know this in your head. So I say, how many combinations can we represent with 2 digits of base 10? Just about everybody would say what? 100. So we got 100 combinations. Well, how do you get that? 10 to the second. So you can calculate in any base, I don't care what base you're in, it's the base raised to the number of digits. So base 10 to the second, that gives me 100 combinations. Now, if you want to calculate the biggest number you can represent, it's x to the n minus 1. So it's x to the n minus 1. This gives you the what? The biggest number. So if I've got 8 digits of base 10, base 2, then that gives me 256 combinations. 2 to the 8, 256. But I can only represent numbers, weighted numbers from 1 to what? 255. 255 would be the biggest number I could represent. So what's the biggest number you could represent with base 10? 2 digits. That's 10 minus 1, which would come up and tell me what? 99. So the base raised to the n power gives you the number of combinations. The base raised to the n power minus 1 gives you the biggest number you can represent, right? Does that make sense? So with 10 bits of binary, I could represent 1,024 combinations. But the biggest number I could represent would be what? 1,023. Okay, any other questions? Okay, guys, let's go to lab. Y'all need to carry all y'all stuff down there, right?